In this episode of the On.NET Show, we'll learn how to use gRPC-Web to build really interesting and really performant web applications using C# and also our Blazor client. So stay tuned and check it out. Hey everyone, welcome to another episode of the On.NET Show. My name is Cecil Phillip, and in this episode, we're going to be learning about how we could do gRPC-Web inside of .NET. And with me today, I have my good friend James, who's going to tell us a little bit about how this whole thing kind of works. But before we do that, James, why don't you tell us a little bit about yourself, like who you are, where do you work, and like how did you get involved in this project?
So my name's James Newton King. I'm an engineer on the .NET team. And for the past year and a half, I've been working to make gRPC a great experience on the .NET ecosystem. And today we're going to talk about using gRPC in the browser using gRPC-Web.
Nice. And James, just for folks that don't know, you're actually the creator of Newtonsoft.json, right? Like that's like your baby, right?
It is.
Nice. So I know tons of folks use that in like all of their web applications and desktop applications and stuff like that. So, it's really great to see you like working on some other really cool projects here inside of the .NET ecosystem.
Yep. I've still touching JSON from time to time, and we'll compare it today with gRPC.
Nice. So why don't we talk about what is gRPC and like why should we care about it? Like why is it interesting and like what's its space here in the .NET ecosystem?
So gRPC, it's a popular open source remote procedure call framework. So RPC frameworks make it easy for apps to talk to each other. There are many alternative RPC frameworks out there. So there's Thrift, and JSON RPC, and WCF. But the overall developer community is really unifying behind gRPC as its framework of choice. So it's run by the CNCF. And what Microsoft has done is we've contributed a gRPC implementation to the Cloud Native Computing Foundation. And we're working with them to make gRPC a great experience in the .NET ecosystem. So gRPC is not new. It was originally open sourced in 2015, but it's a union of two modern technologies. So HTTP2 as its protocol layer, transport protocol, and protobuf is its serialization technology. It's designed for modern apps, particularly microservices. It's high performance and platform independent. There are gRPC implementations for every major computing programming language in use today. So .NET, Go, Rust, Java, C++, Ruby, Python, Node, you name it, there is a gRPC implementation for it. So you might be wondering, why aren't we using gRPC today from browsers if we want to get all these great performance benefits that it offers? And the reason it isn't possible to natively call gRPC from browsers is the REQUEST APIs that exist in JavaScript don't have support for all the HTTP2 features that gRPC needs to be able to natively call gRPC from the browser. So what do we mean by that? Let's take a look at a RESTful HTTP call versus a gRPC one, and then we'll map what they look like in HTTP2. So you don't really need to worry about this level of detail, but it's just sort of interesting to know what's going on behind the scenes and why gRPC-Web is required. So here we've got a basic RESTful JSON call using HTTP 1.1. We've got the headers at the top, just your standard response headers, and then JSON message. So if we map those to HTTP2, we can see what HTTP2 does. It has the idea of frames. So frames are kind of a way to like encapsulate different parts of a request. So in this case, we've got a headers frame where the HTTP 1.1 headers would go, and we've got a data frame. And in this case, the data frame would contain UTF-8 bytes for our JSON message. It gets a bit more complicated with gRPC, but it's still quite similar. So in this case, we've got a gRPC call. Really, the only difference you can see in the headers is the content type. is a bit different. Again, those go into a headers frame. We've got our protobuf message. In this case, it's again hello world. Protobuf is typically binary. In this case, I've represented it in text just so we can read it. Again, that goes into a data frame. But now we've got this extra frame. What is this gRPC status that comes at the end? So what this is, like, it's not being sent in the body, and it's not going in the data frame. The way it gets sent to the server is it comes in as another headers frame. So these are called trailing headers, or just more typically trailers. And you might be wondering, like, why are we doing this? Like if we zoom in on our call, like we've already got a status call coming back from HTTP saying 200, like our request came back okay. Like, what's the point of having this response duplicated down here in this gRPC status header? And the answer to that is streaming. So gRPC, it supports not just sending back a single response with a single message with a response. It supports streaming back multiple messages. So as well as just having a single hello world response, we could have multiple. Imagine we started a streaming call and we sent one request message, and now we're getting back multiple response messages. But what happens if one of these fails? We've already sent our headers with our headers frame because it had to come before our data frame. We need to send a status at the end of our call to say whether the overall streaming call succeeded or failed. And this is done in this status.
So that's kind of interesting. Now, so we have regular headers, we have the body, and then we have those trailers. Mm-hmm. So I'm guessing from a client code's perspective, I could use something like maybe async streams, for instance, maybe, and I could asynchronously loop over a gRPC stream of messages that's coming into me. But yes. Then now you also mentioned that we do have those trailing streams. So I'm kind of wondering, let's say from the server, I sent 5 messages and 4 out of those 5 were successful and 1 was not. Can we go down to the point of saying these were the successful ones and this particular one was not? Or is it kind of like a pass or fail thing on the entire like connection?
So you get back from a client perspective, you get back 1 message at a time. So you would have been able to successfully read 4 of those incoming messages. And then when the 5th one came in, you would have gotten an exception. And that exception would have told you, hey, for some reason, there was a failure with retrieving the data for this 5th and final call. And because of that, you get an error. So from a client perspective, like, you know what you've received, so you're able to tell whether you succeeded or failed. But the way the server tells you that something has failed and gives you that information is in that trailing headers frame. So that's why it's needed when you start getting into more advanced concepts like streaming.
Got it. That makes sense.
So this trailing headers frame, this is part of a reason why gRPC isn't natively callable from a browser, because browser APIs like Fetch and XHR, they don't support reading these trailing headers, so you don't have access to them. And for that reason, you can't create a complete gRPC client in a browser. So the solution to this problem is gRPC-Web. So what gRPC-Web does is it slightly modifies gRPC requests to make them compatible with browser APIs. So those problematic trailers that we can't use in a browser, what gRPC-Web does is, rather than putting them in a trailing headers frame, it puts them at the end of the response body. So it kind of like just hacks them in to the end of the response body. And optionally, gRPC-Web will encode the messages that are coming back as base64. And that's just because of another limitation in browsers around streaming calls. Browsers are able to, browser client APIs like Fetch and XHR, they're able to stream text, but they're not able to stream binary. So if you're doing streaming, you would also base64 encode your messages with gRPC-Web. So the way gRPC-Web works is there is a proxy that sits in between your client, in this case it's the browser, and the server. And what the proxy does is it will automatically get any gRPC-Web calls and it will transform them back into regular gRPC calls, and then it will forward them on to the server. And because of this, the server, as far as it's concerned, is just talking to a normal gRPC client, because the proxy is handling all the transformational stuff. So for this reason, if you're using a proxy, it works with all gRPC implementations. So if you're using Go or Java, C++, .NET, it works with all. And the final part of gRPC-Web is you need a client that sits in a browser to make the request. So there is a JavaScript client that's able to make these kinds of calls. Now, if this all sounds a bit complicated, what we've done in .NET is we've made it much simpler. So gRPC-Web and .NET, you no longer need Envoy. Instead, we have a AspNetCore middleware that acts kind of like an in-process proxy, and it will just automatically transform any gRPC-Web requests it sees coming in, and then it will invoke your gRPC services. Mm-hmm. And all you need to do in the browser is you just add in your middleware into your request pipeline, and then you mark the services that you want to use with gRPC-Web with this enable gRPC-Web metadata. So it's very, very simple and easy to use in .NET, and we'll see that in a demo soon. And then in our client, we also support making gRPC-Web calls from the .NET client. So this is done using a class called gRPC-Web Handler. This is a delegating handler. Think of this like outgoing middleware for the client. And it converts outgoing gRPC calls to gRPC-Web. And the reason why this is useful for .NET developers is it works and supports Blazor WebAssembly. So you can take your Blazor WebAssembly app, you can have a gRPC client, and you can just easily call a gRPC server without needing to worry about the JavaScript client at all.
Nice. So James, when you first said proxy, what I thought about was, hey, can we use YARP for this? YARP would be like an interesting option to be that proxy in the middle. So then now the request would come in, I could hit YARP, and then YARP could, broadcast out into our different things that are there. So I was kind of wondering, like, is that a supported scenario or something that y'all have thought about?
So YARP could do this. Right now, it doesn't have support for it. So Envoy is a popular proxy in the microservices ecosystem, and it has built-in support for doing gRPC web transformations. What we could do is we could take the gRPC web capability that we've added and make it a plugin for YARP. So as well as supporting Envoy in this middle tier, we could also support using something like YARP. But for at the moment, like when you're using .NET, you don't need either because we support it as middleware, so it's kind of like an in-process proxy.
Okay, great. Well, James, why don't we move forward really quickly and show a demo? I know we don't have a ton of time, but I really love to see like the demo that you have.
Awesome. So this is a sample application that shows calling gRPC web from a browser using the JavaScript client, and then it's going to hit the server. So this is a very basic app. As you can see, it's been designed by a developer. So let's say hello.net, and we're going to send what's known as a unary call. That's a single request, single response to the server. And when we click send, we immediately hit a breakpoint in my gRPC service. So we can see we've got our name has come in of .NET. We're going to set that to a message. So we're going to reply hello, and that will go back to the client. And we can see on the client, we've got hello.net. So if we repeat this, very quickly, and then take a look in our network browser. We can see we've made a gRPC web request, and it's gone off to the server using the standard gRPC URL. So if we go and look in our startup class, we can see we've configured that gRPC web client, and we've also configured our gRPC service. So if you've never seen a gRPC service before, they're pretty simple to implement. We're just getting our incoming request, we're getting the name from it, we're setting a reply, and we're sending it back. Now, if we take a look at our console, we can see we've got our incoming request up here. It's HTTP2. The application type is gRPC web text. It's been mapped to our middleware, not our middleware. It's been mapped to our endpoint, and then our endpoint has finished and returned it. So although our server has handled a gRPC call, it never needed to know about gRPC Web, because this middleware that sits in between automatically handled everything for us.
Got it. So I'm wondering, as you're showing this demo, I can use gRPC Web, but I could still use regular gRPC clients, right? Like, it's not
Exactly.
like I can have to use one or the other. I could still use either or.
Yeah, that's an excellent point. So this middleware, it will only process gRPC Web requests that come in that were identified by that content type of application / gRPC Web. So you can use the same gRPC service to serve both regular gRPC clients and also browsers using gRPC Web. If we take a look in the browser, we can see we've got our basic HTML page, we've got some inputs, and then my JavaScript, I'm simply adding some events to our inputs and then working with these generated gRPC types. So gRPC, it uses a lot of code generation. You don't really need to worry about it when you're working with gRPC and .NET, because we will handle all of that code generation for you. In this case, we've got a couple of files here that contain our code-generated content, and you're able to generate those using a command line tool called proxy. So this sample is available in our GitHub repo, and it includes a README file which has details about doing the code generation.
Nice. And so, James, what we'll do is we'll make sure that we share that link with everyone that's watching. We'll put it in the show notes. So if folks are interested, they could go ahead and clone the repo, they could check out the sample, and then they could kind of play around with this and really understand like what's happening here.
Yep. So the final thing I'll show is some of the great performance benefits offered by gRPC Web. So we're going to compare a JSON call, and we'll compare its performance against gRPC Web. So this is a Blazor app. So in this case, I'm making the gRPC web call from within .NET using Blazor, and I'm going to fetch some JSON data first. So I'm fetching weather forecast data, and I've just returned a whole bunch of data, 1,000 rows, and here we can see some details about the response which came back. So our JSON data was 100 kilobytes in size, and it took about 1/3 of a second to deserialize. If we compare that with gRPC Web, we can see gRPC Web is just 1/3 the size, about 30 kilobytes, and deserialization was also 1/3 the time. So it went from about 1/3 of a second to a 1/10 of a second. And we can confirm that by looking in our network browser again. We can see our two sizes, 100 kilobytes versus about 30 kilobytes. And you can see the difference in the content by looking at the response. So with JSON, we've got some big JSON messages coming back, but the protobuf is just binary content. So most of the binary content we can't read, but we can see we've got some UTF-8 strings coming back, which we're able to decode. So that's one of the great things about using gRPC Web. Not only can you like reuse existing gRPC endpoints you have, you get the great performance benefits of much lower network usage and faster deserialization time on the client.
Awesome. Thank you so much, James. So just in wrapping up really quickly, so we can use gRPC-Web so we can use our gRPC services in browser environments, which
Yep.
don't really support some of those other HTTP2 type features. We do the code generation for you, which is really great if you're running with .NET solutions. And then two, we can also benefit from some of those performance benefits as well, which sounds really great. So for all of you that are watching, please definitely go ahead and check out the repo. And I'm sure there'll be docs as well that y'all can definitely go and read and take a look at. If you want to learn more about building gRPC web applications using Blazor, using .NET Core, and also C#. So thank you all for watching. And this has been another episode of the On.NET Show.